Thanks, Hillary. So a lot of these photos are going to be farm-based because that's probably where most of the season extension work is happening on larger scales. But the concepts are still the same for home gardens. And I guess without further ado, we'll get into it. This is a new presentation for me, so sorry if I stop and say, kind of like regather my thoughts. As I started thinking about it, I was thinking, well, what is season extension? I think a lot of us have an idea in our minds, but I then started to wonder, are we really talking about extending your growing time or your time to eat locally or homegrown? I think that's, for the most of us, we're kind of talking about both, but maybe you just really, it's the working with plants that you are most interested in, and that's extending your time growing. But if you're really working on just extending the amount of time in the year that you can eat locally or something that you've produced yourself, then that's not just a season extension of growing, that's extending your eating season. And so as we think about both the plants that we're growing as well as the food that we're eating, it's good to remember that every single plant that we eat, grains, beans, lettuce, kale, tomatoes, any plant, it's either still alive and respiring up until the point we eat it or cook it, or it has been killed and preserved in some way to prevent rot. So in terms of, I was glad to hear Hillary say that we have a root cellaring session coming up, because in terms of your season extension, the traditional ways of extending our season here in New England are still a huge, huge component. One is just root cellaring or some other way of storing food that was grown during the main season. And that would be the first half of what I was just saying about plants we eat, that they're still alive. Those plants are still respiring. They are breathing. They don't have lungs, but they are taking in oxygen and putting out carbon dioxide. And that's also true with a lot of what we're going to talk about with season extension in terms of plants that are still in the ground and haven't been harvested yet. And then, of course, canning, freezing, drying, ways to kill the plant and preserve it to eat it later. So just remember that that's a huge part of season extension, and by no means should it be left behind. It is really what makes what we're about to talk about work well in terms of eating more from your own garden and more locally from the area around you, is the combination of stored food and some fresh food. So in the colder months, that's when we tend to put the most value on fresh greens to supplement these stored foods. So I think probably most of you, correct me if I'm wrong, are thinking of winter growing greens like into the fall, into the winter, or early on in the spring. But much of season extension isn't actually growing the plants so much as it is overwintering them. And you could call that stockpiling, live storage. It's sort of like root cellaring, but without the harvest. You're just keeping the plants alive and respiring, and hopefully also photosynthesizing enough that they're not respiring away all their reserves and becoming this wilted, gross plant that you don't want to eat. So to talk about season extension, I took the tack of addressing what it is that's limiting our normal growing season, and that's really where season extension, we're trying to address these limits. So this will be kind of the foundation, the roadmap of the talk. One of the limits to our growing season is temperature, right? You can only put plants out when it's warm enough, and at the end of the year, the freezes come and kill things off. Everything biological, that respiring, that photosynthesis, those require liquid water for the most part. And then light, because we're dealing with plants that make all their own energy from sunlight. The amount of light we get is the other big limit. And That's both day length, the number of hours of sun during the day, and the intensity of that light. And we'll get more into that in just a minute. We've got some genetics components. You know, we talk in gardening a lot about warm season crops and cool season crops, and we can often grow cool season crops all summer long here in Maine, better than they could maybe down in Florida or something. But we really can't grow warm season crops in the colder times. And that's just really hard to get past. And that's just a function of how that plant evolved, where it evolved, and you know, it's adapted for warmer conditions than we have here. And then to some extent, water. And that's a little bit going back to biological processes require liquid water, but also just some practicalities of growing in cooler months, and some disease potential as well. So we will focus, back to our roadmap idea, we're going to focus in on temperature and light. Normally I would try to break these up, but they're so intertwined for seasonality. Talking about our seasons and gardening, you really can't separate light and temperature. So we're going to try to go through both at the same time. Okay, it all comes down to the Earth's tilt. The Earth is a globe, it has an axis, and it does not sit like this, it sits like this. And that tilt wobbles a little bit, but it's always, you know, in a certain range. And as we go around the sun, that tilt stays the same. So if my head were the sun and my hand here, I don't know if you can see my video, my head were the sun and my hand were the Earth, it's going around me, but it's still maintaining that same tilt. And we'll get a picture here that does a better job of showing that. Here's our spring and autumn equinox, right? First day of spring, first day of fall. It's not that the Earth's axis is still tilted, but we are looking at it head on, so we can't see that tilt. That tilt is, you know, pointing away from us or towards us. So the amount of sun, the amount of light coming from the sun is hitting the northern hemisphere and the southern hemisphere pretty evenly, and our day length is pretty much the exact same on both sides of that. Then we get to the summer solstice, and that's the part of the year where the Earth is going around the sun and it is tilted pointing towards the sun. And so we all know those summer days are longer. We have a lot more time in the light, and as the Earth is rotating around its axis, you know, the hours that we're in the darkness are a lot shorter in the middle of the summer. But in the winter, where we're having a harder time to grow plants, it's the opposite. We have shorter days. And I know I'm kind of stating the obvious, but bear with me. I think this bears repeating. Here's a day length chart for Bangor. I had to choose a city, right? So in the middle of the summer, sorry, not the middle of the summer, in the beginning of the summer, summer solstice, June 21st-ish, our days are 15.5 hours long, almost 16 hours. At the winter solstice, the beginning of winter, they are almost half that. So it's a huge discrepancy in terms of just number of hours of sunlight. And then if we think about the angles at which we're seeing the sun, so in the spring and the fall, you know, we're getting about the same amount of energy on every square foot of Earth in the northern hemisphere as we would be getting in the southern hemisphere. But in the summer, we're tilted so that we're facing the sun. And so it looks to us on Earth as if the sun is higher in the sky, and we're getting a more direct shot. And we're just getting a much greater light intensity. We are like as flat towards the sun as we can get without, you know, or not as flat, but very flat towards how we can get towards the sun, and we're getting much more direct solar intensity. But the winter is, of course, the exact opposite. I don't know what happened to my animation there, but the same idea, you know, the sunlight hitting, and we're facing away. So the sun looks like it's low on the horizon. It's hitting us at an oblique angle. There's a lot less intensity to that sun. You know, it's harder to get a sunburn in the winter. Still possible, but it's harder. So to kind of wrap our heads around this, I thought I was looking out my window at our solar panels, and I thought maybe this is a good metaphor, right? Solar panels aren't quite the exact same thing as leaves, but there's a lot of similarities. We're talking about just the straight up quantity of light and the power of the light. So if we look at the summer solstice or near it, this was the sunniest day I could find in the data. You know, it starts getting sunny a little after 5. It stays light out until after 8. Meanwhile, in the middle of winter or close to the winter solstice, it's not getting light until 7:30, and it's already starting to get dark by 4. The other thing to look at here is the quantity, not just the intensity, not just the quantity. So the quantity would be like the number of hours, right? But the intensity would be the amount of power coming through. And this is at a fixed angle, so it's, you know, just with the sun hitting it at whatever angle the sun can hit it at that time of year. You can see in the summer, getting up to 6 kilowatts, that's the max this system is designed for. But in the winter, peaking out just a little bit above 4 kilowatts. And that is just a direct unit of solar power. So what does that really mean? That means in the summer, something that's like near 50 kilowatt hours of that day of potential energy. In this case, electrical energy, but think about it in your garden plants, that's the same thing as photosynthetic energy. Different efficiencies, and different final products. However, in the winter, same sunny day kind of situation, you're going to get less than half that. So you're just starting out with so much less energy to work with, and the plant that is its food. It needs that energy in order to grow, in order to make new structures, new leaves that you're going to eat later on. If it were a root crop, it needs that energy to make the roots. If it were a fruiting crop, it needs that energy to make the fruits. So one of the big take homes is just like, you know, you're starting off with less energy potential. Your plant maybe can't keep growing. However, well, I'll get into the respiring part in a minute. The other thing to think about that seasonality, here's Augusta, Maine. Here's our temperature logging from the National Weather Service for this year, as well as the normal, right? The normal highs, the normal lows. If you think about the summer solstice, it's right here. The temperature's still been going up just until about then. So even though the days over here are just as long as they are over there, it has taken a while for the ground temperature, the plants, the water temperature, the air temperature to catch up. And then the hottest times are usually after it. And the same is true for the winter solstice, where, you know, the temperatures are still going down, even though the days down here are just as short as they are in January. January and February, as any of us who live here know, is like the most brutal part of the winter. The cold doesn't really happen till after the solstice, even though at that point the days are starting to get a little bit longer already. It's just good to keep that in mind, that the temperature and light are very related, but they're not happening at the exact same time. And that's why it's always going to be easier to extend into the fall season than it is to extend into the spring season. So if you think about plants that you started, you know, if your garden, you expect it to be done in mid-September here, temperatures are still pretty close to how they've been most of the summer, but you're trying to extend into November. Well, it doesn't, you can see that the temperature hasn't it's decreasing, but it's not as cold as it's going to get. Meanwhile, in the spring, you're going to see if you want to start a little earlier than you normally would, the ground's still cold and the air is still cold, and so you have a lot more heat to build up that you need. You're still waiting on that heat buildup to come. So in the fall, you're kind of using borrowed heat from the summer that's slowly radiating away as our days are shorter. Those same length days in the spring you're just like hopefully gaining a little bit more heat each day, but the ground is already cold. And so that is going to affect a lot of what we're doing. And I need to get, oh, it's not showing me where my mouse is. Okay, I'm moving again anyway. So if we think about photosynthesis, kind of what I was just talking about, right? We've got the sun, it's hitting the solar panels on the leaves. They're making energy. And in this picture, that's shown as the orange arrows, right? Sugars are made in the leaves and they go to the flowers and the fruit and to the other leaves and to the roots. And it's a simple equation. If you want to make it simple, boil it way down. This is the simple equation. Water, carbon dioxide, and energy from the light gives us sugar and oxygen. But plants are also respiring, just like you and I. And so in the summer, when they have plenty of sun, they're photosynthesizing way more than they're respiring. So they're making these carbohydrates, these sugars, and that's what they're building the entire plant out of. However, at the same time, they're using some of them to respire. So they're taking these sugars, those energies, and they're running this equation backwards. So you add oxygen and a carbohydrate, happens in our bodies every instant that we're alive. You break apart that carbohydrate, and you get energy and give off water vapor and carbon dioxide. As the days are getting shorter and you have less of this sun, you have less carbohydrates being made, and you're still respiring at the same rate, maybe a little bit less because it's colder, but you're still respiring. So you're still using up those sugars that you're making, and it becomes a balance. And that is going to play a big impact. The other component of that is, here's from my own garden, a nice lettuce going into the fall. The temperature, that's fine. That lettuce, yeah, it's icy. It's well adapted to freezing. This plant is not damaged, not in a great extent anyway. However, that plant is not photosynthesizing because biological processes require liquid water. So it can't quite do what it needs to do to harvest the energy from the sun. So if we go back to our solar example, right, here's our potential energy that our pretend plant is getting on that super sunny summer day. In the winter, it may not thaw enough until maybe halfway through the day. And so that first half of that light energy, it couldn't use anyway. So that means there's even less solar energy available to the plants. That's why it's really hard to grow plants in the dead of winter. And that's why I was talking about stockpiling, or we're sort of overwintering plants to use them later. Elliot Coleman came up with a term for this time of the year when the plants don't really grow much. He calls it the Persephone period. And I blocked it off in blue here for much of Maine. You know, where you are, if you're further north, it's going to last a little longer than this. If you're further south, it's going to be a little shorter than this. But the idea being that in these months where you get less than 10 hours of sunlight a day, the plants are struggling to get enough energy to grow, as well as just the energy they need to stay alive. They may be growing a little bit, but it's not much. And so some of that's just the temperature. So if you had it in a heated greenhouse, but it was just the sunlight and that smaller amount of sunlight, you might shorten this period a little bit because they're able to use more of that energy during the day because they're already thawed out. But in general, about 10 hours is a good estimate for the cutoff of when things just don't really grow very much. Here in Maine. And the other component of this, I think I talked about it generally, but soil temperature also, not only does air temperature lag behind the sunlight that we're getting, but the soil temperature tends to lag behind that air temperature change as well. So in the fall, our nights get cold, but the soil actually stays warm for a while. And so if you can trap that heat in, it's another reason why extending the season into the fall is easier. You're trapping heat in that is really held in reserve in the soil. It's like a thermal battery. You can get a lot more out of your fall season than you can in the spring, because you have cold soil and you got to warm that soil up before you can even think of growing a plant. And warm air, it's going to take a while before that will do anything to warm up the soil. So what are our strategies to ameliorate these cold and dark times, right? What are we going to do? You go whole hog, have a big heated, well-lit greenhouse, add the heat you need, add the supplemental light you need. And for basil, that's a crop that is a warm season crop. Even if you had enough light here and kept it a little bit above freezing, it's not going to be happy in a greenhouse in Maine unless it's really well lit and really well heated. It needs longer days, it needs warmer temperatures. And I mean, that is burning money. And most of us here, we're talking on a garden scale, we're talking about our own use. We don't want to use that much energy because it's going to cost us a lot of money. Also, a lot of us, I assume, are worried about climate effects of what that energy use is, especially a lot of greenhouse heat is propane. It's a fossil fuel. A lot of us are trying to reduce our fossil fuels as much as possible. So the lower tech, the less energy intensive way, again, this is one of those, like, I think we all kind of know what the greenhouse effect is, but it bears a little bit of going through some of it again. You slap a greenhouse covering of some sort over your crop, and this could be a wire hoop with a row cover over it in a low tunnel. This could be a medium tunnel, or some folks have different names, a caterpillar tunnel, where it's larger hoops that you can actually crouch and get under, or it could be a full-on greenhouse with plastic. Whatever it is, the concept is still the same. Some amount of solar energy in the form of light is coming through the covering, the plastic or the row cover, and it is entering. And of course, our plants are taking up some of that light to do their photosynthesis. But that light is also hitting the ground, hitting the plants, hitting surfaces, and getting turned into thermal energy. And so it's heating them up, just like anything black left out in the sun. It absorbs that visible light, it gets hot, and it radiates that heat out. When you put a covering on it, you trap some of that heat and bounce some of it back in, because these coverings tend to let light through more than they let heat through. And that's the gist of it, right? And I do have a light blue and a black here for a reason, because of course, during the day is the only time we're getting this energy coming in. This heat is radiating back out the entire time, but during the day, there's more energy coming in than there's energy being lost. And then at night, there's no more energy coming in, and the same amount of energy is still being lost. So you also have to think about your soil and everything in that structure as a thermal battery. It's a thermal mass. It's heating up, and then during those sunlight hours, it's basically you're adding to that battery, and then overnight it's radiating with no additions, so you're draining the battery. From there, you can get into, there's lots of books written about this, and lots of, I'm sure, articles in our MOFGA newspaper about how to size things. And people like to do like water barrels that are painted black to add thermal mass to a greenhouse type structure. But a lot of what is doing this is the ground. That's heating up, and that is becoming your thermal battery. Sometimes a bit of it's everything in there though. Anything that can absorb that light and get warmer will be doing some of that same function. So then to modify that a little bit, if we add another layer, we're trapping heat in there, and then what leaks out of that first layer gets trapped in the second layer. And so you kind of get different zones that you can create. Elliot Coleman describes each layer as moving you a growing zone south, right? So if your garden is in zone 5 and you put one cover on top of it, then that's like you just moved your garden to zone 6. And if you add another cover, that's like you just moved your garden to zone 7. And I'm sure it's not, a pure one-to-one like that, but that's kind of the idea. You're buying yourself some protection from the extremes of cold. So here's a farm example where they have a full high tunnel. It's unheated. And they also have hoops and row covers. So on a cold night, they're going to close up those high tunnel doors. They're going to put the row cover on top of the plants. And so all the heat that's going into that soil right now is going to be trapped under the row cover. And then what escapes that row cover is going to be trapped in the high tunnel. And then of course it is still losing heat at the same time, but you're trapping as much as you can. And then I think I have another example. Here's another farm where they just have like a little cold frame type thing. And that is doing a lot of protection, but having another layer on it as well does even more protection. Here's an example, another type of hoop that people make. This is just electrical conduit. You can buy it at any hardware store. It's PVC, and it's the kind of thing that they run electrical wire through. If you pound rebar, short stakes of rebar into the soil, and then you put this over that, stretch it to another one, you've just made a hoop, pretty cheap, and you can put row cover over it. This farm, this is after the harvest. They've already let these plants die, but if they were still growing, they could also have row covers underneath this larger hoop. So they could have 3 layers, and that would be even more protection. Of course, every layer is intercepting some of the light penetrating. So it's a trade-off between like how much energy are you giving the plant to grow versus how warm are you keeping them. And it depends a lot on which plants you're using as to how important it is to be on which side of that balancing point. Because some of them are really cold hardy and they don't care if they're really cold. And it's more important that you give them as much solar energy so that they can grow a couple extra days versus if they had another covering on top of them. And it's an art, not a science. No one can tell you the exact answer. A lot of people are still experimenting with these things. So another concept that, you don't have to dwell on this one too much, but it's worth thinking about if you're thinking about this for the first time and maybe investing in some season extension equipment or infrastructure. If we take our little row cover here, let's say it's a 2 foot by 2 foot square. And yes, I'm simplifying, I'm making it a square because the math is easier, but the idea holds true that if you were to double the size of that, or the size of the edges, and you had a 4 foot by 4 foot square, you have taken a surface area, the area, the 2 foot plus 2 foot plus 2 foot is 6 feet. That has a volume of 4 square feet. If you think of that surface area, that's the surface that you're radiating heat out from. That's where you're losing heat. The volume is your thermal mass, because even the air that you heat up in that enclosed space is acting as a thermal battery. There's moisture in the air. That moisture can hold some heat. So if you increase the size, you've just doubled your surface area. You've gone 4 foot plus 4 foot plus 4 foot is now 12 square feet that you're losing heat from. And we're pretending that the ground is like nothing here, but it is kind of our buffer. We want to be connected to the ground. But your volume inside that has just gone all the way up to 16 square feet. And if we do this even more, and so we double it again, our surface area has doubled again, 24 feet of surface area that you can be losing heat from, but our volume is now 64 square feet. And so every time you're doubling that surface area, you're quadrupling your volume, which is really just a way to say, the bigger your space is, the more air and more thermal battery you have, and so the harder it is to change that temperature. It's the same reason why like a big box store, a Target, a Walmart, a Home Depot, they, per cubic foot of air in that space, they lose less heat to the outside than your house does, because your house is only so big, but it still has a front wall, back wall, a side wall, and a roof. Well, so does a giant Home Depot, but the walls are only a little bit bigger and the area inside is a lot bigger. So the larger a structure you can make, the better it's going to be to resist temperature swings. So if you had a nice warm day, a nice fall warm day in the 50s, under that structure, it might get all the way up into the 70s, and then really cold that night, dropping down to the teens. If you have a really small one like this, you're maybe going to be in the 20s inside of it. But a really big one, you might be in the mid to high 20s inside of it. There's a chance you don't even drop below freezing for that long, because you just have that much more buffer, thermal mass as your sort of energy battery. And then of course, put hoops inside of it, et cetera, et cetera. You can see how they work well together. Okay, so that was my temperature and light spiel, as well as some of like how we're trying to hold that temperature in. And of course the light, there's only so much we can do with it. This might be a good time to take a pause, make sure everybody is on the same page. Did I lose anyone?
Haven't had too many questions, Caleb, and so I'm guessing the people are with you. Yep. Corbin says yes.
Great. All right, so some of the genetics, why we choose the crops we choose. What makes a good crop for cold season growing? It really boils down to leafy crops. And that's what I was talking about earlier with that photosynthetic budget and the balancing of energy. Making flowers and fruit or a big root takes a lot of energy from a plant. Whereas when it sends that energy to make a new leaf, it's then able to make even more energy, right? Because that's another solar panel that it just put out there. So in a lower light situation, leafy crops are always going to do better. That's why in the summertime, and people ask me, what can I do with a shady garden spot? I always say, go with greens or herbs, something where it's just leaves. Because it just takes a lot of energy for that plant to make a fruit or a root storage organ. And yeah, here's back to our diagram of it. Just to remember, not only does it take energy to make those, also every bit of the plant is respiring. So when it runs that calculation in reverse, if you have a lot of other structures that are not also making energy, they're costing you even more energy. That's why in a tomato greenhouse where it's really jam-packed full of tall tomato plants, a lot of farmers will start removing the lower leaves because they're not getting that much sun, but they're still costing the plant energy. And here we go back to, oh yes, just the total amount of energy available to the plant, right? We know we're working with a smaller quantity of light, and then we also know with colder temperatures, less of that light is available for harvesting in terms of photosynthesis. And then there's some genetic components of the crops. Where did they evolve? What kind of climate are they adapted to? So membrane lipids and flexibility. We're going back to biology class. Every cell in your body has lipid membranes. And so it's a membrane that wraps around the cell and it protects the cell and it divides the inside from the outside, and it's made up of lipids, fats. And that's true of plants too. And so here's an idea of a plant cell. Plants also have hard cell walls. That's this boxy structure. So in the red, you see lots of membrane lipids, just like in an animal cell. And then plants also have chloroplasts, which are in the green here. And that's where photosynthesis happens. And this has a membrane layer on the outside, an inner membrane layer, and then all of those stacks are called thylakoids. Don't worry about the name. Just know that those little Oreo looking things are just layers and layers and layers and layers and layers of membranes. And those are critical for photosynthesis to work well. It's all about sort of having a gradient of different things on one side versus the other side of that membrane. And it all boils down to these membranes are important. If you think about fats and how they behave at different temperatures, picture coconut oil. It's a really highly saturated fat, which means it's a straight chain. When those highly saturated fats slow down, they get colder, when they're moving in solution colder, they can stack right next to each other, and they get really tightly stacked, and they're rigid. Think about a highly unsaturated fat like olive oil. It takes a really long time. It has to get pretty cold before that gets cloudy. And the ones that are in plants right here, well, it depends on the plants. So some plants that are like tropical, like many of our favorite garden plants, tomatoes, peppers, eggplants, sweet potatoes, basil, those are all tropical plants. They tend to have more saturated fats in their membranes. And in the hot summer, that's great because they need a little bit more structure. If it was all unsaturated, they would be loosey-goosey and they would leak. The membranes would leak and they wouldn't work as well. In the cold months, they're too solid and they start to break apart and they leak. Whereas our cold adapted plants have better membranes there. I'm probably putting too much emphasis on this, but just know that, you know, there are real differences within the plants, and that's why a warm season plant and a cold season plant are just different. They have evolved in many different respects to be well suited for the climate that they're adapted for. This is also the reason why warm season plants get cold injury even if they haven't frozen. Like, they don't need to freeze. The membranes just need to get weird because it's colder, and they'll start to suffer and they can't photosynthesize well. That's why, you know, putting your peppers out early doesn't really help them out. They usually just sit and are unhappy until it's warm enough. Then the other one that is probably more important, doing a lot more of the lion's share of the work, and it's also what we tend to dwell on a lot with winter greens, is osmoticum, your $5 word for the day. In other words, dissolved things in liquid, and antifreeze proteins. So just like we salt the roads, because when you dissolve something in the water, it lowers the freezing point. Salt water it has to get a lot colder before it will freeze solid than fresh water. Same thing is happening in the plants. So back to our cell wall, you know, if it freezes, this structure right here is full of water. It's going to have ice crystals, shards that form, and they're going to puncture membranes. They're going to puncture the cells. And that's how freeze damage and frost damage messes up our plants. That's a lot of what's happening when you actually have a freeze that's damaging things. So what do the plants do? They also do salts that tend to be like nitrate that they are pulling out of the soil, and they accumulate those in that water, in that sort of big balloon of water. They just load it full of salts. And then if they have enough solar energy to make a lot of sugars, or sometimes they have other proteins that they make, non-structural carbohydrate compounds. It just means photosynthetic byproducts or products from photosynthesis that they are not turning into new structures, like they're not making new cells and new leaves out of, and they're actually going to not want to make new leaves out of it because they need it in the water dissolved to lower the freezing point. So that helps the plants that are really cold adapted load up their interior water with salts, proteins, sugars. And that's why that spinach in the middle of winter that you get at the farmer's market tastes so much sweeter than the spinach you get in the summer, because the plant is like loading itself up full of its own antifreeze. So that all needs to happen. And those changes all take some time. That's one reason why an abrupt shift from warm temperatures to cold temperatures, the plant hasn't accumulated these things. It hasn't switched gears to change the lipids in its membrane, because some of that, they can do that to some extent. They, haven't put all the sugars in reserves. They haven't made these proteins that act as antifreeze in place yet. But if you give them time to do it, they get gradually colder day by day by day. They start to do all this stuff, and then they're ready for the really cold temperature. So that gets us to, well, what are the good crops? The quick list, very general terms, brassicas tend to do really well, and we'll get into all of these in a little more detail. Quinopods, which are spinach, beet, chard. Umbels are the carrot family, parsley, parsnips. Alliums, they do really well, onions, garlic, leeks. Asteraceae depends on the plant, but there are some members, like the lettuces, chicory. Radicchio is a chicory, right? And it tends to do well in the cold. And then there's a few other ones that we use that are kind of from different families. Corn mash is a plant that you don't see much, but it's well adapted to winter growing. More farmers would rather grow it in the winter than would grow it in the summer, at least here in Maine. And Claytonia, which can be a bit of a weed, but it is a good for winter growing. So brassicas, I'm going to go through these a little bit one by one, and we'll kind of say, here's a good example. Cabbage. You can stockpile it a little bit into the fall, but it really does great as a storage crop where you have grown it, you cut it, you put it in storage in a root cellar or wherever, what have you. Or maybe you ferment it, but that's a different talk. Whereas broccoli doesn't really store that great off the plant, but you can stockpile it on the plant, and depending on variety, there's variety differences, but some of the broccolis are very cold hardy, and with a little bit of protection, just some row cover, hopefully with a hoop to keep it off the plant, to give it a little airspace. That airspace is what's doing the insulation. You can get into the autumn for a while, and so long after, you can just leave it and let the rest of the ground freeze up, remove your cover, go out, harvest broccoli once in a while, until at some point it's going to get too cold and the plant will die back. Cauliflower, not very good. It just gets diseases in the fall, and it is not as cold hardy as broccoli. So just because broccoli and cauliflower are similar, they're not interchangeable for this use. Kale and collards are excellent stockpiled. They're very cold hardy. It's what they're known for. A lot of people up here don't think about collards because it tends to be, we think of it as a southern crop, but they can often be more cold hardy than kale. So it's often, for winter growing, it's better to do collards than kale, and the use is very similar in the kitchen. They're going to do a tiny bit of growing if they're really well protected and heated, but really the way you want to do this is to stockpile into the winter. Spring turnips, like Hakurei turnips, radishes, they can store well depending on the radish. Some radishes are specifically grown for storage. That's probably the best use of a radish is as a storage crop. But some of like spring radishes, regular old-fashioned garden radishes or spring turnips, they're, in terms of if you want to grow a root crop in the spring or the fall, these would be the ones. They're the fastest of the root crops. They are very cold tolerant. So that would be where you would want to go. Arugula, very cold hardy. I wouldn't bother with it over winter. I wouldn't try to get it through the middle of winter, but it can go into the fall really well. And when you're ready to plant early in the spring, it's a good choice. Asian brassica greens, among the best for winter growing, both for stockpiling as well as getting a little bit of growth in those days when you're actually able to. It depends a lot. There's different species of Asian greens and there's different varieties, and it can, the same species, variety to variety, one can do really well and one doesn't do as well. You got to look to your seed catalogs for good descriptions, and most of them will tell you which ones are the best. And sprouting broccoli is one we don't grow here very often. It's a type of broccoli, and it's actually kind of like a biennial where it's not going to want to make that broccoli head until the next season. And it doesn't make one big head, it makes many little shoots. So it does best if it's overwintered and then you get it in the spring. We're a little cold to overwinter it. It can be done, but you need to have a really good protection system set up. Our quinopods, spinach is probably #1 for our winter growing crop here in Maine. It can also get by with some of the least amount of protection. The main thing, we talk about protection from temperature. The other thing I haven't mentioned enough is you have to be protecting it from desiccation. If you had spinach out in your garden with no covers on it, the cold is going to eventually kill it, but really what's killing it is that the soil freezes. It can't get enough water up from its roots into the leaves, and just cold wind across those leaves is drying them out, and it desiccates. And that's what a lot of our winter injury is from, is desiccation more than cold. I mean, yes, cold is also a big factor. So spinach, as long as you've got some covering to keep it from getting totally dehydrated, ideally shelter it from the coldest shocks, and keep it from oscillating from really high temperatures to really cold temperatures. You know, I was talking about that acclimation of the sugars, the proteins, the things that build up in the plant. You don't want to have it going from hot to cold to hot to cold, because it can't, it's going to be constantly rearranging its membranes and constantly changing what it's storing in its cells. You want to kind of ease it into the cold, let it stay cold until you know it's going to be warm enough that you can bring it back up to the warmth, and it'll start growing again. Chard, that's one where it's not, I wouldn't count on it to do much growing over winter. It's probably going to die in January unless you are good at keeping things warm. And then it's a biennial, so in the spring, it's only going to make a couple new leaves, and then it's going to send up a flower head, and I wouldn't really bother with it. But for stockpiling into the autumn, it is pretty darn cold tolerant. Beets, same as chard, but like, why not just store the beet as a beet? That's, unless you're doing beet greens, and then just kind of treat them like you would chard, maybe a good early seeding crop in the spring. But I would rather just leave them as roots, either in the garden protected so that I can harvest the roots from the garden, or in a root cellar. Carrot family, cilantro, surprisingly cold hardy, stockpiles well. It's another good one to seed again in the early spring as soon as you've got your soil temperatures warm enough. Parsley is very cold hardy. It can be overwintered, and you can, without too much protection, a little bit of protection, and you can continue picking that parsley early on in the spring. It will go to flower that second year because it's a biennial, but you know, you can just have it, you'll probably be able to harvest from it until your next season's parsley are ready to go into the ground anyway. Carrots, again, great storage, and they can actually be overwintered in place in the ground pretty darn well. A little mulch, and as long as you can work the soil and dig them up again, you'll have great tasting carrots up until it's warm enough in the spring that they're trying to resprout and flower. A lot of these crops are biennials, all of our root crops, right? So they grow that first year, and they're just making a storage organ, holding energy until the next year when they want to flower, reproduce, and set seeds. You want to catch them before they go to flower, because that's when the flavors start to go downhill and they get woody and fibrous usually.
Hey,
Parsnip?
Caleb, one
Yes.
question about carrots. One
Yeah.
person asking if they won't go mushy in the ground. Can you just
It depends on the carrot. If they've gone mushy, they've either gotten too cold and just died back, or they suffered from disease. But you can, and it's going to vary sometimes season by season, depends on the year, as well as your protection in place, and as well as how wet the soil is. If you have well-drained soil, you protect it so it's not sitting in water, it's not freezing into a chunk of ice. But you also wait until it's cold enough before you do that, because you want the plant to go dormant before you start to protect it. Then you can overwinter them. And again, this is going to vary by variety. Some of our cold season carrots, you know, you look at variety descriptions, some of them are going to be better for overwintering than others. Oh, and parsnips are one that a lot of people prefer spring dug parsnips, where you dig them before they start to regrow and start to send up a flower head. And those parsnips, that root will actually pull itself under, you know, when you pull parsnips, the top of the root is already below the soil because the plant has pulled itself down. So they're going to be pretty well protected just being deeper in the soil. And often they don't need any protection at all to get through the winter. But of course, carrots and parsnips, great root storage crops as well in a root cellar.
Hey, Caleb, how thick of the mulch would you want to have on top of the carrots?
Couple inches, not much. It depends a little bit on your situation, and what your mulch is. But if it's something a little fluffy, you just need, and also how much snow you normally get. Ideally, you have a little bit of mulch and then snow on top of it. But you don't want to make like a rodent haven. You don't want it actually too warm, because then the carrot is like trying to grow and it's not getting any light. You just want to protect it from the harshest of the cold. And there's probably, I know the root cellaring book that I mentioned, they talk a little bit about clamps and other ways to store a bit in the ground, in situ, without pulling and harvesting. So alliums, leeks hold really well in the field. They can take really cold temperatures, and they don't store so well after being uprooted. You can pull them and their soil root ball and put them into the root cellar like that, where they're still in soil, and that's the way they're root cellared. But if you were a commercial farm with a big cooler, you harvest the leeks, you cut the roots off, and they're only going to be good in that cooler for a week or so. But if they're in soil still, and still like actively growing, or sitting, hoping they can grow again, they will store very well. And this goes, I think we have a picture coming up with a story about leeks. But onions, storage onions, that's the way I want to go. Just grow more onions over the summer and grow storage onions and keep them well stored and enjoy those throughout the winter. But you can, in a high tunnel situation with some protection, you can seed in the fall for spring crop. As far as I'm concerned, in the spring, why not just eat the last of your storage onions and grow some scallions, and then wait until your regular season onions are ready. But I know some people want to do a little bit of everything. I do worry that overwintering onions, you can overwinter onion diseases. So, and I've seen that happen, but hopefully not that much of a problem. Scallions, they go well into the fall. They're pretty cold hardy. And then because they're the cold hardy, you can start them in the spring. So here's my leek story. This was when I was still actively farming. We protected those leeks with hay, but we didn't get to them before the ground had really frozen. So we were out there with like axes, and not axes, but a pickaxe, shovels, anything we could to break up that icy mulch and crack that frost layer in the soil. And you can see the snow was protecting them. As soon as those leeks thawed out, they were great. They were in fine shape. You could eat them just like any other leek. So the plant is very cold tolerant. Few more weeks of these conditions and it probably would have desiccated, right? Because the soils were frozen, the roots couldn't take up more moisture, and those leaves are exposed. Cold winds are going to evaporate moisture out of that leaf. It's just like drying laundry. You can do it on a frozen cold day because the water in the fabric will spontaneously evaporate at some extent. Not as fast as on a hot, dry, sunny day, but it will work in the winter as well. And that's happening in our plant leaves. So our last few crops on what are the good ones? Lettuce, surprisingly cold hardy, variety dependent. Look for good overwinter cold weather lettuces. You can do some winter growing, especially with the smaller ones. If you're trying to grow lettuce heads, I would just stockpile those and then harvest as you can. But if you just need leaves, like leafy lettuce mix, you can get some winter growing. Then radicchio, chicories. So radicchio is very cold hardy in the field. You can protect it and leave it as is and harvest pretty late into the fall. Some of the chicories, that's endive, Belgian endive. I'm sure I'm getting some of these names wrong, but endive, you harvest the root and you bring it inside like a root cellar situation, and then you warm it up and you force it to create a new bit of growth. And then of course the fancy way to do it is to blanch it so that there's no exposure to light, and you get this light yellow whitish endive. And I haven't played around with that enough. I've heard it's just absolutely fantastic, but also maybe an acquired taste. And then corn mosh, that's a funny little plant. It doesn't get very big. They taste delicious, absolutely delicious. They're very cold hardy. And so they can grow with minimal protection through the winter whenever they're getting enough light to actually keep growing. Claytonia, this is another one, sometimes called miner's lettuce. This can become a weed, so be careful, use it. Either let that be part of your philosophy of like, I'm going to let it set seed in this corner of the greenhouse, and that's going to be the Claytonia corner, and every winter I'll just harvest there. Or make sure you're harvesting it before it sets its own seed and drops seed. But it's very cold hardy, and in the middle of winter, a lot of people love it. Peas, not great going into the fall, because if you're trying to actually pick the peas, you got to time it right. And it's hard to time these falls. Is this going to be a fall where it's warm all the way into November? Or is this going to be a fall where it gets cold October 1st and it stays cold all the way into January? So no one really grows peas then usually to harvest at that late in the year. But in the spring, it's one of the earliest plants we can grow. And so you're just trying to get your first pea harvest as early as you can. And then to some extent, water is limiting us. If we look back at this photo we saw earlier, that ground is starting to look pretty dry. It's a little bit of a toss-up, right? This farm can only get the water to the crops when it's warm enough that the water can flow through their plumbing and not freeze up. They can stop it, let the plumbing drain again before it freezes up. The other thing is, once you get warm water in that soil, it doesn't dry out nearly as quickly as it does in the summer. And if you get really wet, really humid conditions in a greenhouse, you can get some diseases like powdery mildews or downy mildews that can spread and go a little nuts. So you want to keep things on the dry side, but not totally dry. The other consideration is, think about that soil. If it were wet, it would be darker, and it would actually warm up a little. It would capture a little more solar energy. And a little more moisture in the air helps to hold a little more thermal mass. So there's some trade-offs. Really, like, can you even just get water to the plants? Are you hauling buckets and filling up watering cans? On the garden scale, that's way more doable than on a farm scale. The other thing is getting excess moisture out. And with our garden scale structures, we're not typically going to have an exhaust fan like this. So how do we get that humid air vented out so that we don't have disease pressure, we don't have it too wet? Okay, so let me check the time. All right, I got to wrap it up. But here are the take-home points. If you're trying to extend your spring season, for warm season crops, your tomatoes, this is the kind of season extension most gardeners are already doing. So don't push it any more than that. Just do your normal gardening advice. As we talked about, these plants are adapted for warm season conditions. It's always going to be a super uphill battle to stretch them too much earlier in the season, unless you've got heated growing space. And congratulations if you do, I'm jealous. Season extension covers will speed growth. So, if you have them out and you're protecting them from frost anyway, that warmer climate is going to be closer to what they want to grow in, and they will do better. But I would err on the side of don't rushing it, and just, wait till June. Get your warm season plants in the ground when you normally would. For your overwintered crops, stuff you planted in the fall and I just need it to stay alive so that it can start growing in the spring. Those plants are going to be on their own schedule. And when it gets warm enough and there's enough light, you're going to see them explode with growth. And that's how you just keep an eye on them. Make sure you give them enough water, especially when they're starting to explode into growth. Don't keep them soggy, don't make it too much water. And protect them from large temperature swings, as we talked about. That big, really hot day, really cold night, it stresses out the plants. So if you can try to moderate that temperature as much as possible, that's the best. For seeding spring crops, new crops that you're seeding in the spring, your soil temperature is your primary limitation. So if it's in a garden and it's just covered in snow, you got to wait for that snow to go away. You got to wait for that soil to warm up. There's some tricks. You can, any kind of covering that you're doing, like for your fall season extension, is going to help keep snow off. The soil is going to be a little drier. And dry soil tends to warm up. I know I was just talking about in the greenhouse, wet soil absorbs solar energy a little more. That's assuming it's already warmish. Cold, wet soil is, you have to evaporate off that water before you're going to get some heat buildup. So in the spring, we want dryish soil so that we don't damage our soil structure when we work it, and also just that it warms up enough. And then those crops you're going to want to protect from the worst cold and the worst wind, just some sort of protection. Here's a commercial farm. They have a heating mat to get their starts going. They have some hoops so that they're going to row cover it, trap that heat in a little bit, because they're trying not to heat their whole greenhouse. Oh, where'd my other picture go? There it is. For the home scale, start seeds indoors. Sorry about that. Start seeds indoors where you're controlling that soil temperature, because for a pea seed, right, it needs a certain amount of heat before it can germinate and get going. So when you have already started it, and these are transplanted pea seedlings, they don't care that they just got snowed on. You know, they're not growing much that day, but they're fine. If you had just put seeds in the soil, that is cold soil, they're going to take days and days and days and days and days to germinate. But if the plant's already started, it can, as a plant, can take colder temperature than it can as a seed trying to germinate. So then really, as I was saying, fall is the time that it's easiest to extend your growing season. So for overwintering field crops, I say plan as usual for your fall crops, right? Do you have things that you plan for your fall garden, a fall planting of brassicas, a fall planting of spinach? Just plant more. And so that you have more that you can stockpile, you can protect and keep it going in towards winter. However, timing is critical, and yet it's the trickiest thing, because we never know, is it going to be a warm fall or a cold fall? And a seedling that's this big in September, if it's a warm fall, is going to keep growing. If it's a cold fall, it's going to just kind of sit there and barely grow. And so it's always good to, commercial farmers always have to do this. They have to do several planting dates, because they never know which one's going to hit right. And so, you know, they do an early-ish one, and maybe that got too big, I'm not going to overwinter that one. They do the middle one, that one turned out to be just right, that's the one I'm protecting. And then they did a late one, oh well, I guess that was a little bit of cover crop that I didn't mean to do, you know, or I harvested it really young, and I'm harvesting it as baby spinach and not full-grown spinach or something like that. In-ground root crops, we were talking about like parsnips and carrots that you can, and to some extent, some people do this with beets with mulch on top. It doesn't always work, but you want to get them towards dormancy, because remember, these are biennials. That root wants to go dormant over winter and then regrow in the spring. So you want them to get cooler, but you don't want the soil to get totally frozen, because you're never going to be able to dig them up again until the following spring, if that's the case. So you want to keep it close to freezing temperature without getting super saturated and frozen, because ice in the soil is what prevents you from getting them up and out. If you have dryish soil, enough moisture that the plants are still living, but dryish, even if it's frozen, it's a lot easier to get into. And of course, sandier soils are going to be easier, because they're going to be on the drier side. They won't stick together as much. Some people will use plastic tarps over that section of row, and they'll come back later. Big caveat, that is like prime habitat for rodents they'll make their winter nest, and they will also eat those root crops, because they're like, hey, you made me a warm, dry spot, and you stocked my pantry. So you'd have to be prepared for that. Some home garden scale, same PVC conduit, row cover, spaced this close together, those hoops that close together, even with just row cover, that's going to withstand most snow. You could get a plastic instead. Here's another one, bigger. This would not withstand snow, right? It's big and flat. It would just get totally bogged down and rip the row cover. Plastic might withstand, but just PVC, those things are probably going to collapse under the weight. Some people use metal conduit. And we have a whole nother webinar from last year on season extension where Dave Coulson goes into more of like different structures to use. And so if you want to go more in depth, there's a lot there. Here's another one. Somebody made their own small hoop house. This is metal fence post that's either been bent, and you can buy benders from Johnny Seed, or there's other sources, and you bend that metal and it's a really strong structure. Here they have greenhouse plastic on it, so it's going to let as much light as possible in, and it's going to trap some heat. If all you're trying to do is overwinter things and you're not really worried about getting new growth, you don't need total light coming in, you can use cheap plastic you buy at the hardware store. Look for something that's UV protected. Greenhouse plastic has things added to it to protect it from the UV, so it holds up in the bright sunlight over time. Hardware store plastic usually doesn't. It usually will last maybe over winter, and then it'll shred and it becomes a mess. So greenhouse plastic is the better option. It's more expensive, so it depends. Are you trying to grow things under it, or are you just trying to keep the wind out and the heat in? You know, you have a little bit of flexibility with what you're doing there. Here's another farmer doing a similar thing. Notice the ropes, that last picture and this one, ropes holding it down on top of the hoops. So something to hold it up and something to hold it on top, because wind can take these coverings and, you know, things to weigh down the edges. And, oh yes, if you are lucky enough to have a big enough structure that you want to seed crops in the fall, either for winter harvest or early spring harvest that you're trying to overwinter them, the goal is that you get your plants about 3/4 of the way to harvest stage by the time you enter the Persephone period. And remember, that's what Elliot Coleman calls the time when day length is less than 10 hours of sun per day. So around here, that's early November. You want to aim to get your plant seeded early enough that it is about 3/4 of the harvest size that you want at the beginning of November. It's a moving target. You know, colder fall, a warmer fall, but Johnny's has a nice sample, a nice guide, right? If you're growing kale, full-size kale, they recommend you use transplants, and they recommend you transplant them 13, 14, or 15 weeks before that Persephone period. If you're doing spinach and you want baby leaf spinach and you're direct seeding, they are recommending that you do it 5 to 6 weeks before that date. And so you're going to have to experiment. This is a good, like, if you've never done it before, use their guidelines and then take good records, because all of our professional farmers struggle with this. You know, last year my seeding on this date did great. This year my seeding on that date is way too big, or it's way too small. It's just a little tricky to balance that, because you never know what the fall weather is going to be like. And I focused a lot on temperature, but a lot of it's light as well. Sometimes we have really cloudy falls and the plants just don't grow as much. If it's a really clear fall, not as many cloudy days, the plants get a lot more solar energy, they grow a lot faster. So try to keep your own records. You know, when did it work well? When did it not? And you don't have to, you know, get as scientific as you want and like trace how many cloudy days and what temperature they were, but more of just, that was a cloudy fall, that was a cold fall. These dates worked well, this date didn't. Okay, and there's our resources. We can stop and talk. I have more photos of some, like a backyard greenhouse I did on a house I used to live in Vermont, if folks want to look at that. But I imagine there's questions to talk about too.
Cool. Yeah, that would be cool to see, Caleb. I do have about maybe 5 or 6 questions on my list here. The first one, somebody was wondering about fennel and dill. Are either of those things you'd recommend?
Yeah, so they're both in the carrot family. Dill's pretty cold hardy. It's maybe not quite as cold hardy as cilantro. So I would use it more on the, like you can extend into the fall with some fresh young plantings of dill. They're not going to die right away at first frost. And if you protect them, they're definitely not going to. And you can plant them pretty early in the spring. I wouldn't try to overwinter it. It's going to just bolt and go to flower. Fennel is also relatively cold hardy. I don't know if it's that cold hardy. The trick with it is that it is the bulb that we're eating, and that's a storage organ. That is like it's sending sugars to make that bulb. So that's kind of like energy intensive. I would think of it like a root crop, even though it's not a true root that you're eating. So it's not, I wouldn't be my first one. Again, you can grow it earlier in the spring than some of our other greens and some of our other crops, and you can get into the fall. It's probably better protected into the fall because if you have good sized fennel, it gets cold enough, you just protect it, it's staying alive. All of a sudden you see really cold forecast, it's going to be 10 degrees at night, and you only have one layer of row cover on it, and you're like, I don't think it's going to make that. You just go harvest your fennel, throw it in the fridge, and you've got another few weeks out of it.
Cool. One person asked, is it true that peppers and eggplants are perennials and that you can bring them in as houseplants until the spring?
It is. They're not going to do much over winter because our days are short. So they're not going to really reproduce. I haven't done this with eggplants, but I have done it with peppers. So I don't know if eggplants are quite a perennial. I mean, I know they'll live more than 1 year, but I don't know if they form a woody shrub the way peppers do. In the tropics, peppers are small woody shrubs. And it varies a little bit species to species. There are different species of peppers, but particularly hot peppers, a lot of them tend to be well suited for this. The issue is every time I bring in a garden plant, I always bring aphids with it, or thrips, or other garden pests that aren't such a big deal outside because there's natural predators eating them. But in my own, when I bring them inside, all of a sudden I have aphids. I'm like, oh no, these are going to go to my other plants. So be really careful. Put it in quarantine, clean it really well. It can be really tricky to get them to overwinter well. I tend to just start my own peppers every year, although sometimes I will bring a plant or two in for the fun of it. Basil is also like this. It's not going to really produce over winter, but in the tropics, it is a little shrub, a woody shrub.
Wow. That kind of connects to another question. Somebody asking about just other herbs that you might be able to, either bring in or stockpile in the garden. I know you've talked about cilantro and dill. What about like rosemary or?
Yeah, some of the perennial herbs are very cold hardy. If you give them a little protection, like sage can last pretty well into the cold. Rosemary, we are on the edge of where you could overwinter rosemary. So if you give it some protection, if you give it enough protection, you can get a rosemary, another woody shrub that gets pretty big, and you actually maybe need to cut it back to get like fresh growth that you want to use. I've seen 3-year-old rosemary plants in greenhouses, but those are like high tunnels. It's without much extra protection, but just the greenhouse itself, that high tunnel is enough to give it that edge where it can overwinter. Some plants do this better than others. Like rosemary, you could probably still get some usable leaves off of it all winter long. A lot of them are going to start to look kind of cruddy until February, March, when the sun returns, and then they're going to have new growth, and that's when they're going to have that reinvigorated growth. This is the same way people do figs. Some people will cut the fig way back, get it the crown dormant in a potted plant, and put that in the basement. You could leave them in a tunnel, and they will often. There's good work. Becky Seidman at the University of New Hampshire is looking at overwintering figs and how much production can you get off of figs in New England. Sorry, I just went from herbs to figs, but it's similar. So there's lots of different plants to explore.
Awesome. Somebody else was asking about spring seeding. They were asking about a good soil temperature to look for in spring when you want to seed cilantro. And I'm also going to add on to that question, sort of like very general seeding dates in early spring for maybe some of these more cold hardy plants that you've been talking about.
Yeah, so the first one is easier because good seed companies, or there's also just information available on the web where you Google the crop type and optimum germination temperature, and you will get results that pop up. The Johnny's catalog is probably familiar to most of us, and along each crop type, they have a little graph of like what is the best germination temperature. If you're a little below that, you may still get germination, but it may take longer, which gives disease more time to cause damping off. Or you may just get less of the seeds actually making it all the way up to germination. If you get too hot, you can impair germination. So I don't know cilantro off the top of my head, but I know exactly where you can find it. And it's pretty quick to look that up. The different seeding dates, that is a really tricky one. And that's because you could be up in the mountains, you could be down by the coast, you could have a big, tall, high tunnel with a high volume of air that warms right up. Some of these high tunnels in January, February are comfortable enough that you're walking around in a t-shirt inside. They get cold overnight, but with some row cover, the soils start to warm up and you can seed. Most people wait till late January or February, but if they have a high tunnel that's warm, that's about as early as some folks are seeding in the new year. At the home garden, if you don't have a high tunnel, it really depends. Maybe you tarp your garden to keep it a little drier. And as soon as you can work that soil, there's a few tests people have. You want it dry enough, so you form a ball, you want it wet enough that it can form a ball, but dry enough that when you poke your finger in the ball, it falls apart into two clean halves. There's the bare bum test, I've heard some folks say, where you drop your trousers and sit on the soil, and if it's comfortable enough that you can put your bare bottom on it, or if you imagine that it's comfortable enough, then that's when you can start thinking about seeding some of the cooler season crops outside, if you don't want to go around to actually measuring the soil temperature.
I love that. Okay, yeah, one of our last questions was about raised beds. So somebody wondering if you could speak to raised beds or planters versus planting in the ground directly, and whether this would make a difference to the length of the growing season.
So raised beds tend to warm up earlier in the spring because they're not holding as much moisture. And then in the fall, they actually can get colder earlier than the soil because they're raised. So they have that surface area on the edges that is radiating heat out. So the soil in that raised bed tends to cool off a little faster than soil in a garden where there is no edge because it's just more soil around it. So it's only losing heat from the top, not the sides as well. A raised bed is losing heat from the top and the sides. If you were to put a cover over the entire raised bed, you're helping to trap in some more of that heat. So it's a little bit of, it's also a smaller quantity of soil, so it's less of a battery, right? You have less thermal mass to hold on to that heat. So they tend to cool off faster, but that also means in the spring they warm up faster. It's a little bit of a trade-off. And my pictures show some raised beds. And my approach, what I did with them, there we go. So there's 3 raised beds under that structure. And that is made with electrical conduit that I just put rebar in the ground on the outside edges of those raised beds, put the conduit over it, and then I found a 45-degree connector for the top and joined 2 pieces of conduit. And I was actually worried about snow load, so I ran rebar through the conduit. If you choose sizes appropriately, you can do that. And then I linked them together, and I made my own little mini greenhouse, and I framed out some doors in between the garden beds. And I did that in March. Transplanted some seedlings of spinach on the 25th and had some direct seeded stuff already popping up. This is in Burlington, Vermont, so sort of like coastal Maine conditions. By April, I had broccoli transplants that had gotten that jump start being indoor transplants. It's warm enough that I'm enjoying my tea in there. This, as a home gardener, this is what I really like about season extension, is that if it's big enough that you can fit in it, you get a little bit of a preview of summer, and you can kind of like just pop up a lawn chair and talk to your plants or whatever you want to do. Then by the end of April, I had spinach that I could start picking leaves off of, and arugula and other things that were starting to get harvestable. And broccoli that it was well on its way.
Beautiful. It's an inspiration.
And this is a reminder, though, you have to always prepare. How are you going to ventilate? Because in May, these can already get way too hot. So you need to be able to open up a side like that.
Yeah. Caleb, one last question. Can you just remind us what the approximate date for entering the Persephone period?
Early November.
Early November. Okay.
And in the resources that I shared with that Johnny's, they have a growers library, and they have some winter growing specific things. They are targeting commercial growers, but it's the same information that you would want to use, right? They give a good estimate for their conditions in Albion, Maine, which is really close to the Common Ground Fairgrounds. And it just kind of gives you a gauge. If you're further north, then know that you're going to have shorter days a little earlier, and they're going to last a little longer. If you're further south, you're going to be able to go a little further into November before plant growth really stops, and you're going to come back out of it again a little earlier.
Right. Okay. So if somebody were to want to try, say, planting spinach this fall, they'd be looking at sort of like a mid-September planting date if they had some plan for protecting that spinach.
Yeah, that sounds about right.
Okay. And there was one last question that got entered into the chat. Robert says, can you also address the sunken bed for a high tunnel application, please?
I think I might know, maybe we're at the point where I'll stop sharing, and we can discuss, and Robert can comment and let me know if I'm on the right track or not. There are some high tunnel designs or greenhouse designs where the roof is basically above ground, but everything else is sort of sunken within the ground. And so you're counting on the soil around you to buffer the temperature swings. And that can work really well. It works a little bit better at lower latitudes. We're a bit far north, where it works really well if you can have a greenhouse roof that still it's angled to catch that winter sun. Our winter sun gets so low that it's really hard. You kind of want to be a little higher up to catch more of that sun. I don't think it works out to be super practical for most of our gardeners. For folks who really want to look into building like a greenhouse type structure, there's a few that may not make as much sense commercially because they're a more initial investment. But if it's part of your lifestyle, the ones that I'm daydreaming about are called climate battery greenhouses. And that's where you have a fan that takes the hot air at the top of the greenhouse and blows it through tubing underneath the soil full of rocks. And during the day, you're charging that soil underneath the greenhouse with heat that's captured at the hottest part of the greenhouse. And at night, that same fan is continuing to blow that air through. And so that heat comes out of that battery, that thermal storage, and warms the air back up again. And so there's a nice book called Forest Greenhouse, maybe, or We can look it up and put it in the email that comes out after this. But this guy out in Colorado has great greenhouses, and he has a sauna in it. And on the coldest nights, he just saunas within the greenhouse. And I'm thinking, like, yeah, that's everything I want in my life. It may not make sense on the commercial scale, right? Like to put that much money into it in terms of selling crops out of it. But for your own home, gosh, that's my daydream.
Oh yeah, that sounds very dreamy. Maybe we can find a link to share about that.
Yeah, yeah. I meant to dig it up and I forgot to add it, but we'll get it out.
Okay, cool. Well, amazingly, we're at 1:30. Thanks so much, Caleb. This was really fun. It's been nice to hear from folks today. Thanks for being here, everyone, and good luck with your fall growing experimentation.